Good day, students. For today, we'll be having a continuation of the last discussion regarding the laws of exponents. So, we'll be applying the laws of exponents this time with the examples that I'll be giving. So, let's begin. Your first example. So, it's 2s squared times 4s raised to 7. So, if you have noticed what the sign, the operation used is what? Multiplication. So basically, what rule applies here? Okay, correct. So the rule that applies here is the multiplicative law of exponent. So it's what you basically call the multiplying of powers. Okay. So if you are to look for the definition of this one, you can go back to you can visit the video last time. Okay, so how do we solve this one? So for me, I group those things that are common. So for example, the 2 and 4, and then the variable s. Okay, and that's up to you also. Okay, so next is you multiply. 2 times 4 is correct, it's 8. How do you multiply this thing? So apply the multiplicative law of exponent. You're just going to add what? Its exponent. Take note, what is the exponent of s here? It's divisible 1, right? So that's it. 1 plus 7, which is equal to 8 times s 1 raised to 1 plus 7, which is equal to 8s 8, right? You get my point? Okay, let's proceed to another example. Okay, this one, 36a raised to 5 b raised to 8 all over, or a raised to negative 4 b times b raised to 5. So here, what law can be applied here? Okay, correct. You may apply the what? Division law of exponent. So if you have questions regarding the sign, they're asking you, can you use the negative law of exponent? Of course, you may, but the division law of exponent may do the process easily, right? Okay, let's proceed. 36 divided by 4. So I prefer simplifying first the numbers so that I may have a better look at the variables later. So again, group those things that are common. 36 over 4, a 5 over a negative 4 times b over it's ba over b5. And then next thing you know is you divide this thing, you'll get 9. Alright, okay, then this one here, this is what I'm saying. So the division law of exponent can easily simplify this one. Okay, so sir, why is it that there's still negative there, and then this one has negative also? So take note that the sign here is negative, right? It's negative, so you also have to copy the sign, right? Okay, and then 8 minus 5, and after that you simplify. So what happened to the sign? It's negative times negative, it becomes positive. And 8 minus, just still copy the others. The next thing is you simplify. 5 plus 4 is 9, and then 8 minus 5 is 3. Do you follow? Okay, good. Let's proceed to number 3. Okay, so here you might have a lot of method that can be applied here, or you might have your own solution. So this is my solution. So I prefer simplifying first the number. Okay, so flip again. This is my first solution. 5 over 30, P5 over P3, Q8 over Q4, and raised to quantity raised to 2. Okay, and let's simplify this thing. We'll get 1/6 and 5 minus 3 and 8 minus 4, Q8 minus 4 raised to 2. So still you need to copy this thing here, the exponent to outside. Next is simplify 5 minus 3 and 8 minus 4, so P squared Q4. Still copy this one. Next is you raise or you do what? The quotient law of exponent, remember? Okay, so quotient law of exponent. Every exponent here must be raised or multiplied by 2. Okay, so what happens? So 1 square over 6 square, P times 2 times 2 times Q raised to 4 times 2, which is equal to P4. So sir, why did you write P4 here? If you multiply the numerator, this thing here, and these two, the P and Q, it will be written in the numerator now. And then why did you did not write the 1 square? So if it's 1, you may not write 1 anymore. So it's invisible 1. And then 6 square is 36. That's the answer. But you can also do this method, the other method. So what do I mean? Let's erase this first. Okay, so again, I simplified the numbers first so that I can get a better picture of this thing here. Again, you may not write 1, but for visual representation, I'm going to show it lang. So here you can directly multiply this thing. It's the square outside in every exponent that this expression contains. So what do I mean? So with this 1 square, 6 square, and then P 5 times 2, 3 P in the denominator, 3 times 2, Q is raised 8 2 times 2, and then Q 4 times 2. Okay, and then you simplify. So you may not write this one anymore since it's 1 now. So P raised to 10, then Q raised to 16, 36, 6 square is 36, and then P 3 times 2, right? And then Q 4 times 2, which is equal to 8. Next thing is you're going to apply the division law of exponent. Okay, division law of exponent naka. Then subtract the exponent. So 10 minus 6, which is then 16 minus 8. So Q 16 minus 8, P 10 minus 6. Sir, why is it 36 is still in the denominator? Of course, it should be in the denominator since it is written here in the denominator. Am I clear? Okay, good. So if you simplify this one, you will get the same answer earlier. Okay, P raised to 4, Q raised to 8, 36. You may ask which is which. It's up to you what method you want to use and which is more convenient. Next, number 4. This might take a while. So here you notice that the exponent is negative, so you need to be careful with the solution. So 20 divided by 4, okay, 20 A5 B5 divided by all over 4 A4 B5. Okay, so here I already simplified this too. 20 divided by 4 is 5 alone. Okay, and then copy the rest. And then, sir, why is it B is gone now? Now take note, if you still remember the negative zero law of exponent, remember B if the numerator is the same with the denominator, it will equal to 1, right? b5 over b5 is equal to b5 minus 5 is equal to b to the power of 0 or equal to 1. And then here you multiply the exponent, so you get 5 to the power of negative 2 and a 5 times negative 2 all over a 4 times raised to 4 times negative 2. And let's simplify. A raised to negative 10. Oh, what happened to 5 squared? Okay, so I already placed it. I took the reciprocal of it and then placed it in the denominator. And then negative 10, negative 8. So this time the division law of exponent applies. A negative 10, negative 10, negative minus the negative 8. And you add, you get a negative 2 all over 25, which is, if you take the reciprocal of this, you will get 1 over 25a squared. Okay, am I clear enough? Okay, let's proceed to the last example. Okay, so this one will really take a while. Okay, so this will be the last one. Okay, sometimes you will encounter expressions like this. Okay, so do not get confused. You just focus on the problem. Okay, so first you need to identify what are the terms that are similar and what are the laws that you need to apply. So my solution is like this. So first is I multiplied the exponent here directly. All the terms that are inside the parentheses here, and in the second parenthesis I took the reciprocal of reciprocated the terms that contains the negative exponent. So this is what happened. The r squared, the r is in the numerator and the s is in the numerator. Next is you subtract what's common here, the t, right? You have the t. And then why is it 9 this time? So remember, we squared it already, right? So 9, then s squared, t, 16 minus 8 because t 16, and then over here t 8. So you subtract the exponent and then all over r squared, all over 3s. Okay, just copy this one. The next is 9s squared t8. Okay, so after you subtract the exponent, you get 16 minus 8. That's 8. Just copy the rest. And then you combine this thing here. So after combining, you get 9r squared s squared t8 3r squared s. Now take note, these two here are the same. So applying the what? Zero law of exponent. Okay, so it's just equal to 1. And then that will give you the answer 3st8. Okay, so in this problem there are a lot of laws that were applied. So from this parenthesis only, you apply the quotient law, and then here in this parenthesis you apply the negative law, and then here you apply the division law, and then you also apply the zero law of exponent. Zero law of exponent, and then that's the last thing, zero law of exponent. So far, if you have questions, you may raise your concerns in the comment sections. Thank you.